So all your basic data is entered, and now it's time to do some calculations. So again, we have the first two balloons. So we had control 3.4 and size 3 point small. It's going to be the same balloons, so you could really select these two cells up here, copy, and paste them in. You'll also paste them for the error and the conclusions. You may want to go ahead and do that right now. Okay, so now we want to do some calculations. We want to turn our frames into time. So you can do that with a combination of the actual frame and the frame rate. So the right way to do that, the way we've been writing it out, although here you can see the fraction is written next to each other, you would take the number of frames, then you multiply by a fraction, and you would get rid of the frames in the denominator, put the time in the numerator. So effectively, since your frame rate of 60 means 1 second per 60 frames, you were taking the number of frames and you're multiplying by 1 over 60. So here, when you calculate, you always have to hit equals. Then you put your number of frames. Now actually, I'm not going to write 75.2. For control, period 3, group 4, I will just say where. I'll give the address of the number. So if I change my number of frames, this automatically updates. So it's in B3. I could type B3, or even better, I could just tap B3. And so then it multiplies by a fraction of 1 second per divide 60 frames. Close the parenthesis. Good to go. There's the time. Now, you can copy and paste this in the next cell. And the nice thing is, since you went down one cell, it actually, if you look at the formula now, it automatically went down. Instead of calling on the frames from B3, it now calls on the frames from B4, which is the correct one. B is in the number 4. Okay, so now we have actual times. And so finally, we can figure out distance because, look at our givens. We have T, we have VI, we have A, and we want D. Well, that fits nicely with D equals VIT plus 1/2 AT squared. Notice I put a 0.5 there, and you'll see it's nicer to put that in your formulas. So actually, we're going to put that in. This is how we program it. It's very easy. Equal sign. So the answer will automatically come out as a distance. We have the initial velocity. Well, the initial velocity, though it is 0, we could change it. And in fact, if you do it the right way here on this file, then you can duplicate it and use it on the next one, and it'll make your life much nicer. So here the initial velocity is in D3, so I'll just click there, times the time. Well, the time I have right here in B9. So I did the VIT there, plus, don't write 1 divide 2, write 0.5 times, we need the acceleration. Well, the acceleration is up here in E3, so we'll touch that, times time squared. So the time is in B9, so we'll touch that again. And how do you do square? Well, you could actually do times B9, or you can do times B9, that up caret 2, and hit return. And so the distance based on this came out to 7.7 meters. Now that's not right. My time is wrong, that distance is wrong, but we're just making up numbers. Now if you copy and paste, pretty cool. This actually jumps right into the distance now based on the small balloon. All right, good. Next calculation you can do is the error. Now here, the actual height came out to approximately 9.35 meters. Mr. T was walking in and I was dangling the tape measure down, so hopefully we got it right. Somewhere around there. For both balloons, they fell about 9.35 meters. There's a number of pieces of error that go into that height, but it's roughly that vicinity. So how do you find the percent error? Well, the formula for it's right up here. It's not a bad idea to write it out in words and then mimic it in the formula. So it's the experimental value minus the actual value, or accepted value, that's ACC. That whole thing divided by the accepted value times 100. So when you write it out this way, it tells you where to make the parentheses. So this is a good coding practice. So equals, we're going to need to double parentheses. Now the experimental value that we got for the height of the control balloon is right here. It's in C9, so I'll just click that. Minus, the actual value is right here next to it in B15. Then see above it closes the parenthesis, divided by the actual value, here that is again in B15. Close the parentheses you see above, times 100. And I have negative 17.6%. I'll copy and paste it. This one, what did I do wrong? Should be good to go. Oh, I see here. So this one is B16. Good. Did I mess that up? Oh, I did. I meant for this to be B15 up here, not B16. Sorry about that. My mistake, B15, and then if you copy and paste that, it will be good. Good. So there's my percent error. It's about 17 and change, 16 and change. You will be far better than that. We'll talk to you about conclusion on the next video.